everybody, this is the first video of the course How the Internet Works. So it will be about 12 or 13 videos, maybe more, in this video series, and we will cover all the topics of How the Internet Works class. My name is Sade Evrenseeker and my webpage is sadeevrenseeker.com. You can put my whole name together and you can access the courses link. You will see How the Internet Works class over there. And there will be a syllabus, the course materials, even these slides or assignments or other things. You can download them and you can keep the track of the course. Okay, let's start with the question, is the internet different? So there are lots of communication technologies, telephony, telegraph, radio signals, television signals. We have used lots of communication technologies for many years. But let me ask, is the internet different? Although internet is another type of communication, it's a net at the end, but there are something more on the internet. For example, we can store some information. We can search for some information. For example, even this video you are watching just now is stored on the internet and you can access it any time and watch it multiple times. So internet provides the communication, that's true, and internet provides something more than the communication. Okay, in this course, we will make a brief introduction to the network theory. Actually, this is not a network theory course, but we will make some introduction to it. We will cover some basic terms. And then we will talk about the internet routing, how the packages on the internet are routed, what are the recovery techniques. So, for example, if something collapses or if some computers goes down, how can we recover the network? And what are the techniques and how is the technology is working. You will be able to understand what is an IP, what is a TCP IP, what are the layers of TCP IP technology, and so on. And we will talk about, for example, emails, spams, how can you avoid these spams, what are the technologies over there. We will build a web page, you will learn some basic HTML and CSS coding techniques. And we will also talk about security, how can you keep your data, your work, your information safe from the others. Okay, so these are the basic key concepts of this course, and we will make the first one, we will make an introduction to the first one. What is the internet made of? Internet is made of a physical layer, first of all. There are physical connections between the computers. So for example, your computer is somehow connected to my computer for watching this video. Not at the same time, perhaps. I have uploaded video perhaps a week ago, days ago, but at the end, my information on my computer is sent to your computer somehow. So there is a connection between these two computers. The video I am shooting just now is stored on a server, and then you can access to the server and download the video. So somehow the information, the data generated by my computer is sent to your computer. So here we can say that there is a connection, a physical connection between all these computers. Okay? This connection can be by sound waves. So for example, you can use radio signals or electrical waves. You can use some copper wires. So you can connect your computer with wires. We call them as network cable or Ethernet cable. Or you can use some optical connection like fiber optics. You can connect computers via fiber optics or laser pointers. You can put two laser sender and receiver. You can transmit some information over these receiver and sender. You can use electromagnetic waves. So all these are considered as mediums, and each of them have different characteristics, different advantages or different disadvantages. So we try to use these environment, the mediums, for communication. And the basic concept in the communication is bit. If we can understand what is a bit, then it is easier to understand how we are communicating or how the computers are processing this information. For example, the voice waves. I'm talking to you, my voice waves are converted to the bits, and computers can transmit this information from one computer to another one. And you are listening to me because my computer has decoded these voices, these voice messages, into some signals and then transferred to your computer. So how can we make these transfer or decoding or encoding operations? Let's start with what is a bit first of all. Okay, so bit is the shortcut of binary digits. So binary means you can have 0 or 1. So in the binary number system, you can have the maximum value of 1. So it's starting from 0. So we can say it is 1 or 0. Just like in decimal. In decimal, the maximum number is 9. So we can have any number from 0 to 9. But in binary number system, we have only 0 and 1. So it can be on or off, yes or no, 1 or 1, high or low. So there are two alternatives at the same time. So in a bit, we can store one of these information. So a bit can be 1 or 0. So it can't be, for example, 0.5, it can't be 8, it can be either 0 or 1, nothing else. So computer engineers implement binary digits in the signal forms. For example, you can consider like this. The plus 12 volt is plus 1 and minus 12 volt is 0. So any signal on the plus 12 or minus 12 is considered as 1 or 0. Okay? So anything between these plus or 12 volts, plus or negative 12 volts, are considered as noise. Okay? But you can make some noise reduction. For example, you can avoid noises by assuming 11 or 10 volts to one of them. Okay? So you can make some rounding up or rounding down. And we have a concept of byte. A byte has a size of 8 bits. Okay, so you can store 8 bits together, and you call it as a byte. So 1 bit can have 2 alternatives. So 8 bits can have 2 to the power of 8 alternatives. So 2 to the power of 8 equals to 256. 256. So there are 256 alternatives you can code in a single byte. Okay. When you start to transfer some information from one computer to another one, you are just making a conversion to the bits. And this conversion requires some information, like an ASCII table. In the ASCII table, it is the shortcut of American Standard Code for information interchange. You see, all the letters have some binary equivalent. So, for example, capital A is 10001. For example, you are making a text message, or you are writing a MSN message or email, let's say a Word document, okay? All the letters you have typed from your keyboard are converted to the binary signals. They are either 1 or 0s, okay? At the end, 8 of these signals are considered as a byte, and it is considered as a character. So it is a letter at the end. This conversion also, the ASCII table has more than this. This is a shortened list of ASCII table, because in the ASCII table we can have 256 alternatives. Here there is maybe 50 or 60 alternatives are shown. But in the ASCII table you can use a conversion from binary to ladder to binary. So any computer receiving these ones and zeros as a signal converts back to the ladders. Okay? And at the same time, ladders are converted to the binary level. So this conversion is the most essential part of communication. Okay, we are communicating with binary signals. We are using these binary signals to convert into the ladders. Okay, here you can see a basic conversion, because we have something more than bytes. We have kilo, mega, giga, and tera concepts. For example, a kilo means 1000. Okay, 1000 actually is in the binary conversion, we consider 2 to the power of 10 as the conversion. For example, if you want to convert mega to kilo, then you can talk about 2 to the power of 10 kilo. Okay? So 1 megabyte is equal to the 2 to the power of 10 kilobytes. And this 2 to the power of 10 is 1024. So each time you need to multiply or divide by 1024. In order to make it easier, we assume this 1024 is equal to 1000 only. Okay, in this course we will assume this as 1000. We will not deal with the rest of 24. So you can make, for example, 1 kilobit is equal to 1000 bits. 2 kilobyte is equal to how many bits? Let's calculate it. So first of all, this byte, the capital letters indicates the byte, and small letters indicates bit. So capital letter B means kilobyte. So first of all, we need to convert it into the bits. So in order to convert a kilobyte to bits, we need to multiply it by 8, because remember, a byte is equal to 8 bits. So here we will make a multiplication by 8, so it is 16 kilobits. And then we can convert it to the bits, and we will multiply it with 1000. It will be 16,000 bits. Okay, and you can make the rest of these calculations, although the answers are here. For example, 12.7 gigabits to the kilobits requires conversion of 10 to the power of 9 and division of 10 to the power of 3, because kilo is 10 to the power of 3 and giga is 10 to the power of 9, or you can make simply 10 to the power of 6. You can add 10 to the power of 6 to the end of this conversion, giga to kilo. Okay? So, what happens during the transmission? In the transmission, actually, we have some binary values, digits. Binary digits. We call it as bit. So, we have bits as zeros and ones. And these zeros and ones are transferred by using the physical layer. In the physical layer, we can have some Wi-Fi adapter, some Ethernet adapter, network adapter. We can use our cellular phone as GSM adapter. So we are converting these binary values into the signals. Signals that can travel on the medium. Okay, and the medium can be a fiber optic cable, a twisted pair cable, copper cable, phone cable. It can be a radio signal. It can be anything. What are these mediums? Let's turn back to some network media. For example, this is called as BNC, British Naval Cable. In the British Naval Cable, the signal is transmitted through this copper wire at the middle layer. And then there is a shield covering it, and there is a metallic shield for avoiding the crosstalk, because each time a signal passes through this copper wire, it creates an electromagnetic wave. And this electromagnetic wave causes other cables to be noised. So any noise effect coming from outside or any electromagnetic signal coming from inside is blocked in this metallic shield. Or you can see about this UTP or SCP, unshielded twisted pair or shielded twisted pair. So in here, for example, you have a shield which is protecting these electromagnetic signals from inside or outside, and you can see some twisted pairs. For example, if you have a loosely twisted pair here, the signal travels faster, okay? Or if you have a hardly twisted pair here, the signal travels slowly. So the reason of this twist is avoiding the crosstalk. For example, the signals travels in a different time. While a signal is here, another signal is here, another signal is here, so they don't affect each other, okay? So this is another technique for avoiding the crosstalk. Or we can have fiber optics, so you can use even some colors for coding some different information on these fiber optics, and it's communicating in the speed of light, almost in the speed of light, because we still need some processing time, and it is reducing the speed, of course, but the speed is enhancing by the time. Okay, so here we have, let's say, transmission rate. How do we calculate the transmission rate? First of all, these basic concepts. What is a latency? When we talk about latency, we are talking about a job, and we are talking about the time to complete this job. So, for example, you are downloading a video from the internet, and latency is the total time you have spent in order to download this video. Okay, so for example, you can access to a web page, you can access to an image, and all these operations require some time. And latency is the total time you have spent. And the signal speed is the speed of waves. So for example, you are starting some communication requests, or you are sending just a signal, a text message, whatever it is, and the speed of signal is the arrival of first signal from one computer to another one. And it is at most 70 to 80% of the light. So this is the best performance for the signal speed, and most of the time we have worse. And the transfer rate, or informally it is called as bandwidth, is the amount of data you can download per second. Okay, so for example, we can talk about 8 megabits per second or 16 megabits per second, which means you can download 16 megabits per second. And this is called as the bandwidth. Okay, so in order to download something, first you need to make a request from the server, and then server responds you. by some computation time, after some computation time. It computes your requests and understands it. Maybe it is an error use request. There is a mistake on the request, or the file has not found. Okay, then this response has been generated. Or you can start your download without any problem. So in this case, server starts to sending some file to your computer. And the time you have spent during this download is the key concept for your transfer rate. So you can calculate your transfer rate by the amount of data you have transferred and the time you have spent. It is just a simple division. Okay? Most of the people can think like this. The signal speed, if the signal speed is high, then the transmission capacity is also high. But these are two different concepts, okay? If, for example, you can think about this road analogy. So we have cars on the road, and let's say if the signal speed is low, then we have slower cars running on this road, okay? So for example, there may be some problems, some pitfalls, some dirt on the road, and the cars are driving slower, okay? But transmission capacity is the bandwidth or width of this road. So for example, if you have a broader road, if you have a wider road, then you may have multiple lines, okay? For example, you have 3 lanes or 5 lanes on the same road. So you can consider transmission capacity as the number of roads, number of lanes, and the signal speed as the speed of cars on this road. So for example, if the signal speed is high and the transmission capacity is high, you can think about an expressway with multiple lanes and faster cars. But a high signal speed doesn't mean a high transmission capacity. For example, we may have a single lane highway. Yes, the speed is high, the cars are faster, but we have only one lane. Or, at the other hand, we can have multiple lanes, but slowly driving cars. If there are some problems on the road, so the cars will drive slowly. Even if you have multiple lanes, the transmission will be slower, the total transmission. And the signal speed can be low and the transmission capacity can be low at the same time. So you have a single lane highway, you have a single lane road, and this road has some problems for driving fast. So this is the worst case you can think about, okay? Okay, how can we increase the speed of the broadband? How can we get a better transfer rate? We can increase the speed of the cars, but there is a physical limit. We can't go beyond a point. So for example, the speed of light is considered as the maximum speed we can achieve. So we are limited somehow with some physical limits. Okay? Although it is up to debate, I mean the speed of light is the maximum speed or not, but let's assume it is, and let's assume we have some limits over here. And also you can have multiple packages, multiple cars at the same time, but again you have some limitations because the number of cars, number of packages you can send per second is limited. Okay? So increasing the number of packages or increasing the speed of the packages have some physical limitations. So the easiest way of solving this problem is using multiple lanes. You can use, for example, you may see some modems, some access points with multiple antenna. The reason of using multiple antenna is using multiple communications at the same time. Instead of a single antenna, you can use multiple antenna and you can use this multiple antenna for multiple communications at the same time. Okay, so we have some enhancements for these communication technologies. Okay, so these are some typical numbers just for comparing these technologies. Although there are some enhancements, some advancements on all these technologies. For example, DSL is, maybe you have heard about ADSL, which is asynchronous digital subscriber line, or synchronous digital HDSL. There are several technologies built on the DSL. And the speed is higher than this. For example, it may go up to 16 megabits per second for now, and it's increasing. The people are studying on it, but this is just a comparison study, so you can get an idea about, for example, modem is working on the phone lines. It is a pair of copper wire. We can carry the phone signals, the voice signals over the phone by using these lines, and the maximum speed we can achieve is 56 kilobits per second. Modem is the shortcut of modulator, demodulator, by the way. And then digital subscriber line is again working on the telephone lines, but now we have two pairs of copper wires. Cable modems is working on cable TV. Ethernet is, maybe you have heard about it as the network cable or network adapter. And you can see this picture here. It is a network cable, and it is going up to 100 gigabits per second. Previously, it was maximum 100 megabit per second. Now it is 1,000 times faster than the previous ones. And wireless access is 54 megabits per second. Although there are some varieties for these wireless access, for example, it is 802.11g. You can have A, H, B, other technologies instead of this ladder. So it's indicating the sub-technology for the wireless connection. And the speed is increasing by the time. People are working on it. But just get an idea. So the best connection speed is Ethernet for connecting. Also, you can get some fiber optic connections, which is not listed here. Fiber optic is much more faster than the lists here. But let's assume Ethernet is the fastest one, and you can compare the others with respect to the Ethernet. Okay, how can we calculate the total transfer time? You are transferring a file. Let's assume you have a music file you want to download from the internet. Let's assume it's an MP3 file. Okay, and the size is 3.5 megabytes. So it is a capital B, and we assume it's a byte, not the bit. So 3.5 megabyte music file will be downloaded with 56 kilobits per second modem. So the speed is 56 kilobits per second. And we are asking, how long will it take to download a single file with the given bandwidth, given connection speed? So it is an easy question. First of all, we need to convert all these data, all these numbers into the same unit. And then we will make a division because it is a megabyte and this is a kilobits per second. First, let's convert all the values into the bytes. So 3.5 megabyte will be converted as 3.5 million bytes because we are just multiplying by 10 to the power of 6. So you can think about like this. Each time we are adding 3 zeros, and when we convert from megabyte to kilobyte, it is 1000. When we convert from kilobyte to byte, it is another 1000. So 1000 and 1000 makes a million for the conversion. And 56 kilobits per second, it is again bits, and it is in the kilobits. So if we want to transfer it to the bytes, first we will divide this value with 8 because it is in the bits. In order to convert it into the bytes, we need to divide it by 8. So 56 divided by 8 is 7. And it is kilobytes now, 7 kilobytes. If we want to convert it to the bytes, byte per second, then it is 7,000 bytes per second. Okay, so first you divide by 8 and then multiply by 1000. The reason of division by 8 is converting from bit to byte. The reason of multiplication by 1000 is converting from kilobytes to bytes. And now we have 3.5 million bytes divided by 7 bytes per second. If you divide these information, you will have 500 seconds. And if you convert this to the minutes by dividing 60 seconds per minute, then it is 8.20 seconds, 8 minutes and 20 seconds, you can call it like this. So a file of size 3.5 megabytes with the connection speed of 56 kilobits will be transferred in 8 minutes and 20 seconds. Okay, this is a basic calculation. And what is the actual transfer rate? Now you are asked to find your transfer rate, your bandwidth. Okay, so maybe you want to download some movie and you know the size of the movie and you can calculate how long does it take to download this movie. So you can calculate your transfer rate. Okay, you are paying some money for your transfer rates. You know, there are lots of communication companies selling you some bandwidths. They say this is faster, and you want to check it. If it is true or not, then you download a movie or an image, a music file, and then you calculate the time required for downloading this movie, and then you can make a calculation of the transfer rate. It's an easy division again. So we will divide this the kilobyte value, because it's a capital B, kilobyte to seconds. So we will find kilobytes per second, or you can convert it to kilobits per second. In the connection speed, the transfer rates, the bandwidth, most of the time we use bits or kilobits or megabits instead of bytes per second, okay? It is a tradition to call it as bits per second or kilobits or megabits per second, okay? We don't use bytes per second in the connection speeds most of the time. There are some exceptions, of course. So here we have 5 kilobytes divided by 5 half second, okay? 0.5 seconds, half seconds. So if you divide it, we will have 1000 kilobytes per second, but it's bytes. In order to convert this byte to bits, we need to multiply it by 8, so 1000 kilobytes per second will become 8000 kilobits per second. Okay, now we have the connection speed, the transfer rate as 8000 kilobits per second. Or you can even convert it to 8 megabits per second, because 8000 kilobits can be converted as 8 megabits per second. Okay, this is an application, this is a question for you. There is a video, a 2-minute video, and the size of video is 13 megabytes. You are asked to calculate the bandwidth required for streaming this video without delay. So you want to watch this video online, and the video size is 13 megabytes, and the length of video is 2 minutes. So what is the required bandwidth for watching this video without any delays, without any cuts, without any stops? The question is very easy. You need to make a calculation for 13 megabytes within 2 minutes, okay? So because if you can download this video earlier than 2 minutes, then you can watch video without any delays. But if it exceeds 2 minutes to download this video, then you will have some delays while waiting to download. In the second part of this question, we are asked to find what if the connection speed is 56 kilobits per second and we have somehow downloaded a part of video in advance. So we started to download the video earlier than the streaming, and then we have a connection of 56 kilobits per second. What is the size required to download before starting the stream? Okay, so it is an easy question again. You can simply calculate the amount of video, the size of video you can download with 56 kilobits per second within 2 minutes. And then you can subtract this value from the total size of the file. Okay, it's an application for you. You can do it by yourself. And if you have any problems, you can easily comment out below this video, and I can try to answer these questions. Okay, we can jump over the reviews, and I think we can stop in here. So that's all for the first class. And we have just started, and it's just warming up. In the next classes, we will have something more interesting. So I will try to keep shooting videos, but this is not a promise. So I will do my best, and I hope these videos will help you to make some reviews or to understand these concepts. These videos doesn't cover all the topics I have covered in the classes, so I strongly suggest you to come to the classes. But if you miss some classes somehow, or if you want to make some reviews of the classes, then you can watch these videos. These videos are not a substitution of the classes, so be careful about attending to the classes. So I wish you best.